Now we will be proceeding with our frictional force topic. Now this friction can be classified into total three types. There are total three types named as static frictional force, kinetic friction and rolling friction. Now if you observe on the first name, carefully try to observe it, the word static does make some sense. That means all we need to think about over here is that any object, whichever is stationary, can be termed as static friction. Now please note, if both these surfaces, say for example, if you are talking about the notebook and the tabletop, both were stationary in our example, none of them were moving. That is why whatever there is a frictional force between these two surfaces, that frictional force will be termed as a static frictional force. Now over here I would like to inform you about one more thing, is that let it be any sort of force, it is always dependent on total two things. First is nothing but called as coefficient of friction and another is a normal reaction. Regarding normal reaction, we do know that it is nothing but opposite reaction to that of our weight, and coefficient of friction, which is denoted by mu, is a quality of a surface. So let's come back to our original topic, that was nothing but static force of friction. To be specific, static force of friction is denoted by Fs. As I told you, it is dependent on these two things, mu and N, which is nothing but normal reaction. This mu is what we name as coefficient of static friction. It is a property of a surface. So, proceeding ahead, next type of frictional force is nothing but kinetic force of friction. Whenever either of two surfaces or both the surfaces, if either of them or both of them are moving in a certain direction, then in that case, whatever there is a frictional force between these two surfaces, we call it a kinetic force of friction. This kinetic force of friction is denoted by Fk. Again, this time as well, it is dependent on mu and N itself. Only difference is that this time we refer that mu as a kinetic force of coefficient or simply coefficient of kinetic friction. It is again dependent on the nature of the surface. Moving ahead, this rolling force of friction. Rolling force of friction as well is dependent on coefficient of rolling friction denoted by mu r and a normal reaction. Now friends, you need to remember one thing, that this order which involves first static force of friction, second kinetic force of friction and third rolling force of friction. This order is very important because as we move from static force of friction till rolling, we will come to know that static force of friction is the most powerful of them all, whereas rolling force of friction is the weakest among them all. So soon we will be proceeding ahead to understand which are the laws that govern static force of friction and what are the laws behind kinetic force of friction. So let's understand it one by one. Now in case of static force of friction, all we need to understand, first thing is that this static force of friction is directly proportional to the normal reaction. Now as you know, normal reaction is a function of a weight that the body generates. So simply speaking, more the weight body is having, more amount of frictional force it will be providing. Of course, we are talking about static force of friction. And another thing is that this static force of friction will always have a direction which is opposite to that of the applied force. That means हम लोग किसी भी एक डायरेक्शन में ये बॉडी को मूव करने की कोशिश करेंगे, this force, this static force of friction will be generated and it will be always acting against our force itself. So far we have understood one fact, that static force of friction is dependent on mu, coefficient of static friction, as well as it is dependent on normal reaction. Now one thing is important over here is that, please note, over here normal reaction is very significant. Let me tell you why. Because normal reaction is a directly job or a function of a weight. That means all static friction is dependent on simply the weight or normal reaction of that object. Exactly how much area is in contact with another surface, that doesn't really matter. What is the shape of that object which is generating frictional force absolutely does not matter. As long as normal reaction is same, none of these things matter. Only that object's weight or its normal reaction and coefficient of static friction, that means mu s, these two things will govern how much frictional force is going to be there. Okay, so this was regarding laws of static friction. Now we are going to see about laws of kinetic friction. There is a similarity, a bit of similarity between kinetic friction and the static friction. Let me tell you about that similarity. Both static as well as kinetic friction, both are dependent on normal reaction itself. Actually, they are directly proportional to the normal reaction. So naturally, over here as well, the weight of an object is going to play a vital role. One more thing is that in case of a kinetic force of friction, of course, the nature and material of the surface plays a crucial role over here. It is very much important. And one more thing is that in case of kinetic force of friction, up to a certain limit, please mark these words carefully, up to a certain limit, up to a certain velocity, actually how much velocity is there, that really doesn't matter. It is this kinetic force of friction is independent of the velocity, but please note it is okay, it is true only till a certain value of the velocity. If the velocity is too high, in that case kinetic force of friction is supposed to increase. The same thing that happens in case of a racing cars. So for time being, what we have learned so far is that static force of friction is dependent on normal reaction. It is directly proportional with two things. First is coefficient of static friction. It is a constant, mu s is a constant, and also it is dependent. It is directly proportional to the normal reaction, which is denoted by n. Direction of the static force of friction will be tangential to that of the surfaces which are in contact with each other. Proceeding ahead, in case of kinetic force of friction, it is dependent on again normal reaction, that means weight of that object. Also it is dependent on coefficient of kinetic friction denoted by mu k. This kinetic force of friction is denoted by Fk. Another thing is that up to a certain velocity, this kinetic force of friction is independent of that of velocity, but this is true only up to a certain value of velocity. If the velocity is too high, this theory will not hold true. Now the next topic what we are going to see is nothing but hydrostatic pressure. Okay, so let me tell you, as I told you, traditional physics had a problem. It was a crucial problem. Let me tell you what that problem was. There are total 4 to 5 containers. In these containers, up to a height, liquid has been filled up. Say for example, water has been filled up. Now the thing you are supposed to notice over here is that all 4 containers were made of the same material, same amount of liquid that has been poured into these vessels, and height of liquid in all these vessels is similar. But one thing that is different in all these 4 containers is that its base area. That base area is different everywhere. Few containers is having that very least amount of base area, some of them are having high amount of basal area. Now, in 18th century, this was the main problem that was pursuing the scientists. Problem was that even if the amount of liquid is almost same, still everywhere, for every container, the amount of pressure that the liquid was accessing on this vessel was same everywhere. So cause still remains at large. We still need to understand why exactly this is happening. Now let me tell you, this happens because of these surfaces, boundaries. Now I would like to inform you about, concentrate on vessel number first. Now in this vessel, the bottom area as well as the vertical sides all are flat. Now in this case, there is absolutely no reaction force that would be generated by the walls of that vessel. But the same thing cannot be said true in case of that second vessel. Second vessel does have inclined sides. The same thing is true in case of third vessel as well. Now, because of these forces, since they are directed in different directions, they need to be resolved so that their resolved vectors are along x and y axis, and when these all x and y axis forces are summed up together, a total effective force, a resultant force is calculated for all the 3 of them. It will come to the same point, you will get a same value for the same, and all this is happening just because of the inclined surfaces of the vessel. So that is what we need to discuss about hydrostatic pressure. Now another thing what we need to understand over here is that viscosity. Now please note, It is the myth that frictional force is to exist only in case of solids. Actually speaking, in any case of fluid, frictional force exists. The only difference is that, as I told you earlier, it is dependent on nature of surface and its material as well. Even a liquid, a fluid, can be considered as layers of a liquid, several layers put together. And what physics believes, whenever any two surfaces, let it be of any material, if they are in contact with each other, that means frictional force is supposed to be there. Now, whatever frictional force is there between any two surfaces of a liquid, that is, we don't refer it as frictional force. Since we are talking about liquids, we name it as viscous force. Now, here is the example. Take two liquids, for example, water and honey. In case of water and honey, if both of them, if you pour on ground, do let me know exactly which of these liquids will occupy maximum area possible. Of course, your answer is going to be water. Honey, on the other hand, will try to occupy as least area possible. Now, the reason is nothing but viscous force. Since we do know that viscous force is a frictional force, honey has a high amount of viscous force. And this is the reason the motion of the honey will get obstructed, will get restricted to a certain limit. And that is why honey will not occupy maximum area. The same case cannot be said true in case of water. Water will be able to flow freely since viscosity of water is least compared to honey. So this is nothing but about viscous force. We will be discussing more about this topic soon.